Alright, what's up guys? In this video, I'm going to pick up some calculus here. It's going to be another integration practice video. It's going to be example number 33 of the series. So we got this definite integral from 1 to e. We got ln squared of x and dx. So we know to integrate ln of x, we're going to apply integration by parts. So that's exactly what we're going to do here. Also notice that since we have ln squared of x, we're going to have to apply integration by parts twice. So let's go ahead and get started with it. So hopefully you remember the integration by parts formula. It's the integral of u dv is equal to uv minus the integral of v du. So we need a u and a dv. Now clearly u here is just going to be ln squared of x because we would have to know the answer ahead of time if we let that equal dv, because we know we would have to integrate the dv to get v. So obviously the best selection for u there would be ln squared of x, and then that means that dv is everything else. So dv is just dx. And now we go through the whole process. So what's the derivative of ln squared of x? Well, if you use the chain rule, this will simply just give us 2 ln of x all over x. Don't forget to multiply it by dx. And then our v here will be the antiderivative of dv. So that's the antiderivative of dx, which we know is just x. And so when we go and apply our integration by parts formula, we'll end up with x times ln squared of x. I'm going to pull out the 2, and if we simplify on the inside, we'll be integrating ln of x dx. And evaluating that from 1 to e. So, as I mentioned, we now have to integrate ln of x dx, which we know requires integration by parts. Okay. And again, you know, u is just ln of x, dv. Again, it's just going to be dx. So that means that du is 1 over x dx, and v is the antiderivative of dv. So that's the antiderivative of dx, which we know is just x. And so what do we get? So it looks like we'll get x times ln of x, and then it's going to be minus the integral of dx, which we know is just going to give us an x. So if we combine our first integration by parts and the integration that we took care of for the last part, if we combine everything together, we'll get x times ln squared of x minus 2. Then this would be x times ln of x minus x. And again, that's from 1 to e. Now you plug everything in. So we'll get e ln squared of e minus 2 e times ln of e minus e. That's just going to give us an e. And then we stick in the 1. So we'll have 1 times ln squared of 1 minus 2. And we'll have 1 multiplied by ln of 1 minus 1. And that's just going to give us 2. Therefore, for our final answer, we can go ahead and write that down. So our final answer here for the integral from 1 to e ln squared of x dx, so our answer here is going to be e minus 2. Alright, so I hope that made sense. And that's going to take care of our integration practice. Alright, so let me know if you got any questions. I'll see you next time.